We've been playing with numbers as we've learned about variables and other bits, but let's talk about them a bit more seriously. In the real world, we all deal with numbers all the time. The score on the big game, how many days of vacation we have left, or how many cookies our favorite recipe will make when we make 4.5 batches. Also, in the real world, we often don't think about the types of numbers that we're using. We happily add and subtract, multiply and divide, whole numbers and partial numbers all the time, at least with the help of a calculator, right? Well, Python doesn't care what kinds of numbers that we use either. Numbers are numbers are numbers. The only possible exception is when we're dealing with floats. They're not exactly like the decimal numbers we all learned about in elementary school, but they're pretty close. Let's hop over to Workspaces and look at some examples of working with numbers in Python. We call whole numbers ints, or integers. Int is more common because that's the class name in Python. They work just like you're used to numbers working when you do math or anything else numeric, right? You can do 5 plus 5 and get 10, 2 minus 2 and get 0, 10, and then we use the star as times. So 10 times 18 is 180, and then we use the forward slash or slash, whatever you want to think of that one as, for division, and 8 divided by 2 gives us back 4.0. Let's talk about that one. 4.0. We call numbers with decimals, or points in them, floats. Notice that we got back a float when we did division. Addition, subtraction, and multiplication always give us back ints unless we're working with floats. But division always gives a float. Now this is a difference between Python 2 and Python 3. Python 2 would always give back ints if you used nothing but ints. Python 3 fixed that by giving back floats when appropriate. Actually, always, because they're always appropriate. Oh, and one other thing to watch out for is division by 0. Dividing by 0 gives us back a new error, which we have to watch out for, which is the zero division error. You tried to divide by 0, and you can't do that. So we'll need to be careful with that. We don't want to create any black holes or anything like that. So let's play with floats a little bit. If we do 5.0 plus 2.5, we get back 7.5. And 1.2 plus 0.3, we get back 1.5. Now, floats work mostly like ints do, but they can sometimes be tricky. This is due to them actually being a human understandable representation of a more mathematically pure number. They can represent a huge range of numbers with a very specific amount of precision. This, though, sometimes makes them do, well, weird things. Let's do 0.1 plus 0.1 plus 0.1. minus 0.3. Now that should be 0, right? Instead we get this number, and that looks way bigger than 0, because that's got 5.5. But it's actually not. Notice at the end that there is this e minus 17. If you haven't seen this notation before, or this way of writing numbers, it actually means that the number is raised, e stands for exponent, to the power of negative 17. That means there's basically 17 zeros between the decimal point and this infinitesimal value. So let's use the round function. Let's copy this. Highlight that, copy, round, and then paste. We'll use the round function, which rounds a float to the nearest whole number. And if we do that, we see that it's 0. It's effectively 0. Now, if we were doing some serious banking math with this, we'd have to be more careful, and we'd probably want to be using a more money-appropriate number type anyway. There are some of those in Python, but we're not going to get to them. Round gives us the integer that's closest to the float that we have. But what about if we need to make an int from a float, and we don't care about rounding, we just want the int value? We can use the int function to do this. We can do int 5.2, and we get back 5. And if we do int 5.9, if it was rounded, we would get 6, but we just get 5 because that's the int value. Int just chops off the float portion and just turns it into ints. Int also lets us turn strings into ints. That's assuming that the string is just an int. We couldn't do int a. That gives us a value error because there's no such thing as the number a in base 10. We can do the same thing with floats. We can do float and a number, and it'll give us the float value of that number.
or float and a string, and it will give us the float version of that string. And just like you did math back in school, we can control the order of operations. Now, Python understands the standard order of operations on its own. If we were to do 5 plus 5 times 2, we get back 15. If you didn't do order of operations, which says multiplication comes before addition, or if Python didn't do it, Python just did the math from left to right, we would get back 20 instead of 15. 5 plus 5 being 10, times 2 being 20. If we want that, though, we can use parentheses to control the order. So we can do parentheses 5 plus 5 times 2, and we get 20. Again, just like math class. We can also use the plus equals or the minus equals when we have numbers in a variable. So let's say we have age equals 34. We can say age plus equals 7, and this is the same. If we look at age is 41, this would be the same as us doing age equals age plus 7, which we're not going to do. We can also do this the other way around and do age minus equals, say, 5. And if we look at age, it's now 36. And again, this would be the same idea of us doing age equals age minus 5. But we're not going to do that. So the next time that you have to take a math test, take some Python with you.
Numbers are usually a pretty common part of programming. We end up coding a lot of things that have to deal with money or quantities or all sorts of other things that we have to deal with numerically. The int and float functions are really most useful when we're dealing with input from users that we can't guarantee the type of. We'll be doing some of that at the end of this course, so be sure to stick around. Now, though, let's see about expanding our cast of characters and take a look at strings.